Hello everyone, welcome to this video. This is a practice test on subnetting. So thank you guys for joining me. Sorry, there's been a slight delay with getting this video out. First question is, what are the three stages of the design process of IB subnetting? So there's three stages when it comes to the design process. Please have a think. Please take the time, pause the video if you like, and resume when you're ready. I'll give yourselves a moment to do that. Okay, so I hope you've taken the time to pause the video. If you're not, please do it now. Else I shall proceed with the answer. So the answer is, first we need to analyze the needs, then design the subnets, and then plan implementation. So let's break that all down. So when it comes to analyzing needs, we need to think about how many subnets we need, how many hosts per subnet. For example, we've got a bank that we said, a new bank we're opening, and say, okay, we've got different departments, so we need different subnets. So let's say we've got, let's say we have, in this bank, we've got 4 departments, so we need 4 subnets to be created. And so this is the kind of things we need to think about. How many subnets, how many hosts per subnet, how many hosts do you have in each subnet? So for example, in each department might be, let's say, 20 end devices, including PCs and laptops. So you got your desktop PCs, your laptops, also printers, wireless access points. So several types of devices connecting. So let's say we have 20 on each. So we need, in total, we've got 20 per subnet, 20 hosts per subnet. 2 is designing the subnet. So we need to choose our network, choose the one mask, list out all of our subnets, and then finally planning the implementation. So we need to assign a subnet to each location. So if we've got we've got several branch offices, for example, we've got a banking firm based in California, and you've got a branch in Los Angeles, you've got a branch in Palo Alto, you've got a branch in for example, Cupertino and Santa Clara, and we've got several branch offices. We need to assign a subnet for each location. So we assign subnet 1 to Santa Clara, subnet 2 to Los Angeles, subnet 3 to Palo Alto, subnet 4 to San Francisco. So assigning subnet to each location, we identified, but we also need to identify our static IPs, those that we want to save for static IPs, and identifying our DHCP ranges. So those are things that we want to be thinking about. Okay. Question number 2, true or false? One of the golden rules in subnetting is that addresses in different subnets need to be separated by a router. So it's true or false? One of the golden rules of subnetting is that addresses in different subnets need to be separated by a router. Please take the time to pause the video and play when you're ready. I'll give yourselves a moment to do that. Okay. The answer is true. So addresses in different subnets should be separated by a router. Now, question number 3, fill in the blank. A network engineer should plan subnet for every VLAN, Ethernet WAN, and X. What is X? Again, please pause the video and play when you're ready. I'll give yourself a moment. Okay, and the answer is a point-to-point serial link. So a network engineer should plan a subnet for every VLAN, every Ethernet WAN, and every serial point-to-point link. Okay, next question. Question number 4, true or false? Class D IP addresses are reserved for multicast addresses. Class D IP addresses are reserved for multicast addresses. Please take time to have a think. Please pause the video. I'll give yourselves a moment to do that. Okay, so the answer is true. So Class D IP addresses are reserved for multicast. I'll show you here. So if you see here, we've got Class D 224 to 239. That's reserved there. That's for multicast addressing. So let's get into the final question here. The final question is, right, so Bank in Edinburgh has the IP address 197.73.151.19, subnet mask of 26. So 197.73.151.19, that, okay, that's one of the IP addresses. And please, can you work out, so subnet mask of 26/26, please work out the subnet ID, please work out the first usable IP address of that subnet, the last usable IP address of the subnet, and the broadcast IP address of the subnet. Please take time, pause the video, and play when you're ready. I'll give yourselves a moment to do this. Okay, hope you take the time to do that. I'm going to play down, so if you're not doing it, I'll give yourselves 5 more seconds. So 5, 4, 3, 2, 1, 0. Okay, the answer, okay, there's several aspects to this question. So the answer is right. Okay, so on the whiteboard, so that was the IP address of the that was one of the bank's IP addresses. That's the IP address in question, /26 subnet mask. Let's just write this out first. So 197, okay, is .73.151.19. That's written out then in binary. Then let's write out the subnet mask. Okay, so 26/26. That means there's 26 bits that are on, bits that are number 1. So we write them out. 8 bits here, 8 bits here, 8 bits here. That's 3 octets full of ones. And the last octet, so we're now, this is 24 bits. So we need 2 more bits to make 26, right? And then, so that's 2 bits there. And then here we've got 6 bits remaining. So if you break this down into portions, this all becomes here. That's all the network portion. This is the subnet portion, okay? These 2 bits, okay, that have been that at one point were taken away from this host portion to go from /24, because it's the class C IP addresses, and the class C IP addresses normally would have by default 24 bits, but then when you do your subnetting, that can be /25, /26, /27, /28. In this case, it's /26. So at one point, the 2 bits were taken away, and that became the subnet portion. These final 6 bits are the host portion. So there's several aspects to this, right? And there's a method that I would normally use, and it's called I call it the Big 5 method. If I can get this whiteboard here to show you guys. But what's happening is you've got here basically this is what I refer to. So number 1, how many subnets are being made? We break down our subnetting with this process. How many subnets are being made? So x is how many bits are on, and 2 to the power of x gives you the number of subnets that are being created. So what we do is we need to look at how many bits we want to know how many subnets are being created right here. So here we got 2 to the power of 2, right? That gives us 4. Okay, because there's 2 bits on, so that's in the subnet portion. 2 bits there, that's where we're getting 2 from. 2 to the power of 2 is 4. So we've got 4 subnets being created. Now let's look at the host portion. There's 6 zeros here. So what we need to do here is now 2 to the power of how many unmasked bits there are. So in this case, it's 6 unmasked bits. So that's 2 to the power of 6 minus 2. Why are we doing minus 2? Is because one IP address needs to be reserved for the subnet ID, and the other needs to be reserved for the broadcast IP address. So what we're doing is here 2 to the power of 6 to the power of 6. Okay, 6 in relation to 6 unmasked bits here. So that's 2 times 2, which is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Minus 2 now, we don't forget to do this. 64 minus 2 is 62. Okay, 62 62 host IP addresses per subnet. There's 4 subnets, 62 host IP addresses available. Now we need to work out what's called the magic number. The magic number. How do we work this out is 256 minus the magic is that magic number. This is not very clear, but 256 minus subnet mask. What that means is, in over here, what we have is, what you can see, 197.73.151.19.26, right? That was the IP address in question. 255.255.255.192 is that subnet mask written out in dotted decimal notation. Now, if you look at that last value, 192, that is the magic number there, that's what helps us create this magic number, the incremental value. So that number extremely important. That is what I'm referring to as the that subnet mask value. So what we do is 256 minus 192. That gives us 64. That is the magic number here. That's the incremental value that we use. So that's 64. That means all of our subnets go up in 64. 64, okay? From one subnet to the next subnet, we're going up in 64. Right, so what happens here now? Let's write out our subnets. So we start off 197.73.151.0, okay? So that's the first IP address in this subnet, the first subnet. But that is the subnet ID, that's the result of the subnet ID. The first usable IP address is the one that follows, so that's .1. Then let's what's easier to do is from this subnet ID, let's go to the next subnet ID, because we know that's just adding 64 on. So okay, we add 64 on 197.73.151.64. That is the subnet ID of the next subnet. Now let's go backwards. Because the broadcast IP address is just the one that's before it, so right? So it's just the one going before it. So we just need to take one out, and we get 197.173.151.63. That is the broadcast IP address. Now let's go one back prior, right? We'll go one back prior, because that is the last IP address that was available in the previous subnet. That was the last host IP address available in the previous subnet. So that is just taking one from the broadcast IP address. So that's .62 now. So this, I think, helps was when you go from one subnet ID to the next one, and then you kind of work backwards. You kind of start a subnet ID, you figure out the next IP address. You start a subnet ID, and then the next IP address is going to be the first usable IP address. Then you go on to the next subnet ID, which is just adding the magic number on to the subnet ID, to the last value in the subnet ID. So from .0 we go to .64. That's the subnet ID of the subnet 2, and then we just work backwards to fill out the broadcast IP address and the last usable IP address of the previous subnet, as we're doing here. It just makes it easier. And then for the next subnet is just add 1 to get to .65. Then if you were to work out the subnet ID of the next one, I didn't do that here, but if you were to do that, it would be .128, and then you just work backwards. .127 is the broadcast IP address of subnet 2, and .126 the last usable IP address of subnet 2. Right? Easy. So that brings me to the end of this practice test. So I hope you benefited from this video, guys. Thank you so much for watching, and I will see you in the next video. Thank you. Goodbye.